Welcome back, class 11th. In the previous lecture, we have discussed about the projectile motion, and we have solved and we have proved three equations. First, for the time of flight or the flight time, that is 2u sine theta upon g, where u is the initial velocity, theta is the angle at which the object is projected, the projectile is projected, and the acceleration due to gravity g, that is constant. Then the height of the projectile was u square sine square theta upon 2g. Same thing again. And the last range was equal to u square sine 2 theta over g. So after these three equations, we have to discuss about the next topic. In this equation, in this projectile motion, you have seen the projectile was projected from the ground at some angle, say theta, with some velocity, say u, initial velocity u. This was from ground. Now today we are going to discuss about when you are projecting any object from some height, means standing from a tower, then what will be the equation at that time. And simply we can say, we can throw it in the upward direction, we can throw it in the means horizontally, and we can release it freely. So free fall motion we have seen up to class 10. This one, projecting in upward direction, we have seen here. And now the same thing we are going to discuss, but you or the person is standing from a tower or from a height, that we are going to discuss. And one more thing, in the last day, in the topic of range, we have discussed that to get the maximum range, we have to throw, or you can say you have to project the object at an angle 45 degree. So for that, one case is this, second case is this, and the third case is this. This is at 30 degree, the first one, the smaller one is at 30 degree, and the most which is going on the top is 60 degree, and the last in the middle one is 45 degree. So you can see at 30 degree and at 60 degree the range is same. Why? Right here the theta 30 degree, so sine 2 into 30 becomes 60, and if we are putting the sine, means 60 degree, so sine 2 into 60 means 120, sine 120 means sine 90 plus 30 degree, means sine 90 plus theta cos 30 degree, and the value of cos 30 and value of sine 60 is what? Same. So that is why the range for the either 30 degree and 60 degree is same. The maximum value will be at 45 degree. Now let's move to the next topic, projection from a height. So see here, I am drawing a tower. Suppose from this height, this object is going to be projected, and the object is projected in this direction. After this, it comes to ground like this. This is suppose the ground. So at this level, we also need again the angle of projection. Let the angle of projection here be theta with initial velocity again u. So this velocity, due to this velocity, the object is going forward and in upward direction too, forward and upward direction in both directions. So the horizontal component, same way, will be ux, and that will be what? U cos theta, if this angle is theta, and here I'm just erasing this, and same way in this direction also one component, that will be what? U sin theta. See what is happening. I am throwing an object from a tower. Suppose this height of this tower be small h. From this height, I am throwing one object. The velocity is in upward direction. velocity component is in upward direction, and the displacement is going down from this point to this point, from here to here. This is the displacement, and further this is the displacement. Means the velocity in upward direction, displacement in the downward direction, both are in opposite direction. Means between them one will be negative. So we are having the general equation that, not S, because in the vertical motion we can say H is equal to ut plus half gt square. The simple equation it is. But here, if you are taking the displacement negative, suppose minus h, as the velocity is upward direction, so the displacement I am taking in the negative. So again ut, and suppose here again the velocity is in upward direction and the acceleration due to gravity is in downward direction. So again this will be negative. So instead of positive, minus half gt square. Okay. Or you can take the height, the displacement in the, that means positive. So the acceleration due to gravity positive. Only one thing will be negative, that will be what? The velocity. So easy way is this: take the h positive, take the value of acceleration due to gravity positive, only put negative for the velocity. Now we have taken one equation that we are going to follow this equation. So I am just writing here with negative sign. And now the h will be as it is here, because the height of the tower is h, is equal to the vertical component. So sorry, not ux, vertical component I am talking about. So uy. So right here minus u sine theta, and t is what? The time taken from here to here, means what? Time of flight. You can write directly t plus half g capital T, the time of flight square. From this equation we can calculate the time if the rest of the values are given. Very easy. If you know what is the height of the tower, with what initial velocity you are throwing, the acceleration to gravity is constant, so we can calculate our time of flight. Or in the other word, the time of flight is given, so other things we can calculate. This is just a mathematics. Now the next thing, we are going to calculate about the range. What range will be here? Same thing again, the ux component and the time of flight. From here, whatever you will calculate. So what you got? Ux means u cos theta into time t. So this is the range. Now this was the case when object was thrown in upward direction. It was thrown in upward direction. Now suppose the object is thrown in horizontal direction, in this way. At that time, what will be the angle? See here, the angle is theta here right now. When it will be thrown in, means I'm going to draw the diagram. Let's screen it and draw the diagram. So see here, at this time, from the top, this is the earlier diagram. I'm placing here for the reference when you will see. Now I'm placing the same thing here, same object, but it is thrown in this direction. This is the ground. Here is the velocity, initial velocity, suppose u. Now it will not have the two component at this point. At this point it will have component in that forward and the downward, because at this time the object is only going in forward direction. Here it will have two component, but here it is having only one component, suppose u. So angle here, angle of projection theta is equal to what? 0 degree. So let's put this value theta is equal to 0 degree here. What you will get, h is equal to, if the height of the tower is again same, nothing is changed here. So h is equal to, see here, put the theta 0, sine 0 value 0, h is equal to only half g t square, means time of flight that we can calculate is 2h upon g, and this is the time of flight. And what about the range? Cos 0 value 1, means r is equal to u into capital T, or T has equation right now, so r is equal to u under root 2h upon g. So these are the two different type of, or you can say special cases, when the object is thrown in upward direction and when from a tower, and when object is thrown horizontally from the tower. Now again, if you remember, when we had started this topic about the projectile motion, we arrived, means we proved one equation for the parabolic part. That equation was y is equal to tan theta into into x minus g upon 2 u square cos square theta into x square. In this equation we said that y linear in y, quadratic in x, that's why the path is parabolic. In this place, at this situation, remember again, we had started with the value of x. At that time I had taken u cos theta into time, but here x will be odd, only u and time t. And when you will put the same u into t here in the y is equal to, I'm again writing the equation to memorize you, to again write this equation, minus half gt square. That was because it was thrown in this direction, but here it will be positive, only u will be negative. Actually it is not u, because don't put negative, because u value is in this direction, and this part is for what? The horizontal component, and here vertical component, not horizontal, that is vertical component. So vertical component means u sin theta. If you remember, u sin theta and the value of t x upon u cos theta, that is why it was making tan theta. So here vertical component is 0, so h will be what here? H is equal to this component becomes 0, only you are getting half gt square. Now similarly, if without doing these things, if I am going to put the value of angle 0 here, what you will get? Y is equal to, see, using you can also use this one, because that will be a little bit difficult for you. That's quite easy. So half g value of t x upon u, so x square upon u square. So this time this will be the equation of the trajectory, and again this is linear in y, quadratic in x, means again the equation represents the this path is parabola. And the next topic is about the effect of air. If you remember, when we had started the parabolic projectile motion, I told you whatever the path is visible, if you remember that in that diagram, it was started from here. I told you that this is the expected path, but in actually it will fall somewhere here. So this is due to the effect of air. That's nothing big deal in the question. So starting with the one example, that is example 31. If magnitude of vector A plus vector B is equal to the magnitude of vector A difference vector B, then prove that vector A and vector B are mutually perpendicular to each other. So for that, let's do that. This is square on both sides. I'm writing from here because it may take some space. Mod vector A plus vector B square is equal to mod vector A minus vector B all square. So what will be here? It will looking like right now magnitude. So it will look like here vector A plus vector B dot vector A plus vector B is equal to again here vector A minus vector B dot vector A minus vector B. Let's multiply. What you will get? Vector A dot vector A plus vector A dot vector B plus vector B dot vector A plus vector B dot vector B. Same way here also, vector A dot vector A minus vector A dot vector B minus vector B dot vector A plus vector B dot vector B. We are taking the dot product because in the dot product the product of two vectors is commutative in the dot, not in the cross. So here, and one more thing, the product of a vector with itself is the square of its magnitude only in the dot product, not in the cross product, because in the cross product it becomes 0. So here what you will say, this one A square plus, see here 2 times A dot B is equal to vector B dot A. It's commutative. I just few seconds ago I said to you. So I'm writing direct twice A B cos theta in the dot product AB cos theta plus b square. Same way here is equal to a square minus twice ab cos theta plus b square. So now it's in magnitude, a square and b square will be cancelled and 2ab taken this side. The total becomes 4ab cos theta is equal to 0. This one cancelled and 2ab and 2ab. When it will come to this side, this will become 4. This is again a constant value. So again cos theta is equal to 0. So cos theta again is equal to, when it is 0, at cos 90 degree. Cos cancelled, so theta will be what? 90 degree. So we have proved that angle between the vector A and vector B is 90. Now the next question is from the question 15 part 2. In this question it is written that vector A is this, vector B is this, calculate the angle between them. In this type of question you will use what? That dot product, because you need only the angle, not the direction. So do the dot product, means let's write here vector A dot vector B will be what? A B cos theta, or simply cos theta is equal to vector A dot vector B upon AB. This A and B is what? The magnitude. So let's write here I magnitude of A, it's 1, so 1 square, 2, so 2 square, 1, so 1 square. Same way on solving here, you know that product of I and I, j and j, k and k will give you value, rest of them will be 0. So I dot I means minus 1, 2 plus 1 plus 2, minus 1 minus 2 minus 2, so plus 2 upon 1 plus 4 plus 1, 4 plus 2, 6, root 6 into 4 plus 2 again, root 6. So root 6, 1 root will come out. So 2, 4 minus 1 means 3 upon 6 means 1 upon 2. This is what? Cos theta, and cos theta is equal to 1 upon 2 for the angle of cos for 1 upon 2. So right here cos 60 degree is equal to 1 upon 2. Cos cancelled, so theta is equal to 60 degree. One more question I have taken, that if magnitude of cross product of two vectors is equal to the dot product of two vectors, then find the angle between them. So right here A cross B is what? A into B sin theta. So A B sin theta, and A dot B is what? A B cos theta. These are what? Magnitude will be cancelled. So remaining what? Sin theta, and take that here upon cos theta is equal to what? 1, means tan theta is equal to 1. So at which angle it is happening? So you can write here at tan 45 degree. So theta is equal to what? 45 degree. In some time it is asked in the pi value, so you can calculate that. So let's see the next question. Again I have taken some 2 questions. There are a number of questions, but I have a limited time as you are not putting any questions, so I will select of my own. So the question is, displacement is given 2y 3j 5k, force is given 5i 2j and 3k cap. Calculate the work done. Work done is equal to what? Force into displacement. You must remember that the work done is equal to force into displacement, but which product? Dot product. In the dot product only I and I value will be obtained. So 2 into 5, 10, 3 to the 6 and 5 to the 18. 10, 6 and 18. So it becomes 34 around. That joule will be work done. So easy. Same way here, one more question like that. Vector A cross vector B is equal to AB. Again what you will get? AB sin theta is equal to AB. AB will be cancelled. Sin theta is equal to 1. So at what angle? The sin theta is 90 degree. So these type of questions are there. Many questions are there. Put one question against me, I will solve that. Till then, be safe. Thank you.